Okay, if you take a look at example 2, it says we have a solid figure over here composed of a right cylinder and a hemisphere as shown. The density of the solid is 100 kilograms per cubic meter. What is the mass of the solid? So first of all, let's do a little science discussion here. How adept you guys are at science. What is the mass? What type of units come in mass? Grams, kilograms, those types of things, right? And it tells us right here the density of the solid is 100 grams per cubic meter. Density is typically has to do with either mass or weight per volume. All right, so anytime you see a density, it's usually some amount of mass or weight over volume. So the fact it's 100 kilograms per cubic meter tells me if I figure out the volume of this object in cubic meters, I can then use my density in order to get the correct answer. What we notice about this figure, hopefully, is we have a cylinder with a hemisphere being half a sphere on top of it. So if a full sphere volume is equal to 4/3 pi r cubed, what do you think we'd have to do to that formula to do a half a sphere?
Do it and then just divide by 2.
Yeah, half the volume, right? So we can either find the volume of a whole sphere, divide by 2, or we can create just a hemisphere formula if we want to. The volume of a hemisphere, I'm going to put HS for hemisphere, is just the volume of a sphere times a half. All right. If I multiply 4/3 times a half, what do I get? 4/3 times 1/2. 4/6. What's another version of that? 2/3, right? The 2 and the 4 reduce. So if the full sphere is 4/3 pi r cubed, half a sphere, again, the official name of this is a hemisphere. Half a sphere would be 2/3 pi r cubed, just half as much as a full sphere. All right. So for this particular hemisphere in this particular problem, you'll notice that the radius is right here. Down here it tells us diameter, not a radius. This is diameter is equal to 2 meters, so the radius is equal to 1 meter. So we have two problems here. We have to find the volume of the hemisphere. We'll use the hemisphere volume formula. We have to find the volume of the cylinder. It goes back to chapter 11.2, area of base times height. We add those two volumes together to get the volume of the entire thing in cubic meters, and then every cubic meter gets me 100 kilograms. So we'll find the mass. So that's our plan here. So we'll start with the hemisphere. The radius is equal to 1 meter. So the volume of the hemisphere is going to be 2/3 times pi, which is 3.14, times 1 cubed, which is 1. All right, so if we put 1 meter right there, 1 cubed is 1. So to get the answer, I just have to do 2 times 3.14 divided by 3. 2 times 3.14 divided by 3 comes out to 2.09. Cubic meters. Okay, for the cylinder, going back to chapter 11.2, how we found the cylinder formulas, or the area volume was, first off we drew the base. The base is a circle, radius 1. We find the area of the base, which is pi times the radius squared. That's just 3.14 times 1, so 3.14 square meters is the area of the base. The height of the solid is 3 meters. And again, I'm worried about just the cylinder, so the cylinder starts here, it ends here, the distance between the two bases is 3 meters. So we find the height in the three-dimensional picture, we don't have to draw it on our paper. So the volume of the cylinder is going to be the area of the base, which is 3.14, times the height, which is 3, so the volume of the cylinder comes out to 3 times 3.14 is 9.42 cubic meters. So the volume of the entire thing, the cylinder added to the hemisphere, we just add up the two volumes. So I added plus 2.09 So 11.51 cubic meters would be the volume of this composite figure. And once I've found the volume, so the total volume, let's put V sub T for total volume. Once I know the total volume, if I want to know the mass of the solid, I simply take the density, which is this. All you have to do to find the mass of anything, if you know its density, is you take its volume times its density. So just, again, this is a science formula. Mass equals density times volume. Because if I multiply that number there, put this over 1, times 100 kilograms per cubic meter. And notice the way this fraction is written here, 100 kilograms per cubic meter. That puts a cubic meter in the numerator and a cubic meter in the denominator for cancellation purposes. The unit left over, of course, is our mass unit of kilograms. So multiplication will get us the answer we're looking for. So 1,151 kilograms would be the mass of this particular solid figure. So you're responsible for finding the volume and surface area of a sphere and being able to include spheres and composite figures. So volumes of pyramids and cones and cylinders and prisms, in addition to all the sphere stuff, is going to come into play in this chapter.